Now let us prove root 2 is rational. Already we know root 2 is rational, but we have a method, we have a mathematical method to prove that root 2 is rational. Already we know root 2 is irrational because it's non-terminating, not repeating decimal. And now let us assume that root 2 is rational. Now, what is the definition of rational? By the definition of rational, by the definition, rational means it can be written in the form of P by Q or A by B, anything you can be written. A comma B belongs to integers. B not equal to 0. A and B are coprimes. Now, please, we are going to use this condition and prove that root 2 is irrational. Now, for example, what is the definition of coprime? Let us come. Suppose, for example, I am going to take 4, comma 5. Now, what are the factors of 4? 1, 4, 2 2s are means 1, comma 2, comma 4. Now come to 5. 1, comma 5. Now, in these 2, 4 and 5, the common factor has only 1. That means there is no common factor for 4 and 5. These type of numbers are called coprime. Coprime means only one has the common factor. Suppose let us take 3, comma 9. What are the factors of 3? 1, comma 3. What are the factors of 9? 1, comma 3, comma 9. That means, now what is the common factor here? 1 and also 3. So, these two are not coprimes. These 4 and 5 are coprimes. This pair is known as a coprime. But what about this pair? Only 1 has the common factor, I told you. But here 3 is also the common factor. So, 3 and 9 are not coprimes. Now, did you understand about coprimes? Now, let us come back. Let us come back to the question. In this proving root 2 is irrational, we are going to use this condition A and B are coprimes. Now let us come. Now here squaring on both sides. Root 2 whole square. Square root to cancel. 2 is equal to, for both square, a square by b square. Now do the cross multiplication. 2b square equal to a square. Now b square is equal to a square by 2. Now here a condition. If 2 divides a square, means 2 divides a square, it is also divides its base. That condition is going to use 2 divides a square. 2 also divides a. Means a also divided by 2. If we divide a with 2, we can get a quotient c. That means c is the quotient. Now a value is 2 is dividing. If it goes that side, it will multiply 2c. Now I am going to substitute this a value 2c in this equation. 2b square equal to a square. 2b square equal to, what is the value of a? 2c. This 2 square belongs to the both. 2b square equal to 4c square. Now 2 ones are 2 twos are. And now b square is equal to 2c square. And now 2 is multiplying here. So b square by 2 equal to c square. Now again we use the condition here in the above. 2 divides a square, 2 also divides a. Means here also 2 divides b square. 2 divides b square. Then 2 also divides b. Means its base is also divides 2. 2 also divides b. So b also divided by 2, then the quotient is d. From this equation, from equation 1 and this equation 2, from 1 into from 1 into a and b are divided by 2. Means what? A and B are not coprimes because only one has the common factor for both A and B. So A and B are not coprimes because 2 is the common factor for the both. 2 is the common factor for the both. So our assumption, we assumed that root 2 is rational as A and B are coprimes, but our assumption is wrong here. Is a contradiction. So root 2 is not rational. Means our assumption is wrong. That assumption arisen. Root 2 is not rational. So root 2 is irrational. It's proved.